section 6.3 is solving systems using elimination. Now, when we're using the elimination method, it says you use the addition and subtraction properties of equality to add or subtract equations in order to eliminate a variable in a system. Now, with math, when you eliminate, how do you make something become zero? If it's a positive, you're going to subtract or add the opposite, right? If it's a negative, you're going to add or add the opposite again, right? So we want to make sure that we have inverses so that we can cancel out one of the variables. Okay? All right. So problem 1 is solving a system by adding equations. So here we're going to add the equations. Now, for problem A, we've got 5x minus 6y is equal to negative 32. The second equation is 3x plus 6y is equal to 48. Do you see in that pair of equations where I have a pair of inverses? Yes?
Negative 6y.
Oh, very good. We've got the negative 6y and the positive 6y. So if I am adding these equations, I have negative 6y plus a 6y. That will cancel out. That will cancel out, right? So what we end up, if we add the rest of the stuff, we add the rest of the equation, we've got 5x plus 3x is equal to 8x equals negative 32 plus 48 is going to be 16. And now, how do I get the x by itself?
Divide by 8.
Divide by 8. So x is equal to 2. So now, because we eliminated the y, we solved for x. Now we're going to take this 2, and what do you think we're going to do?
Put it in for x.
Put it in for x. So I'll put it in to the original one. So we have 5 times 2 minus 6y is equal to negative 32. And now we just solve for y. So we've got 10 minus 6y is equal to negative 32. Then we will subtract 10 on both sides. So negative 6y is equal to a negative 42. Then we'll divide by a negative 6.
7.
And y is equal to 7. So my solution then is x comma y again, which is
2, 7.
very good. 2, 7. So for the second example, we're going to add the two equations again. And you can see that we have a pair of inverses, the negative 3x and the positive 3x. Those will cancel out. Those will cancel out. Now we can continue adding the equations. So we have negative 3y plus negative 4y, which is equal to a negative 7y, is equal to 9 plus 5, which is
14.
Good. Then we'll divide by negative 7, and y is equal to negative 2. So now we're going to take that negative 2 and we will substitute it in to the original for the y. So we have negative 3x minus 3 times negative 2 is equal to 9. So negative 3x plus 6 is equal to 9. Subtract 6 on both sides. So negative 3x is equal to 3 dividing by -3, and x is equal to -1. So my solution is x comma y, -1 comma -2. Very good. Now how would I check to see if I got the right solution? Plug it into one of the original equations. Very good. All right. All right, problem 2 is solving a system by subtracting equations. Okay, so in this one, we're writing the equation, okay, the two equations. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? Okay, so where is my first equation going to come from? Very good. Okay, and then my second equation? Very good. Now, the first thing we want to do is define our variables. Okay, so we can say x is equal to the time for the cars. Okay, and the y is equal to the time for the trucks. So 2 cars would be 2 times x plus 3 trucks would be plus 3y, and that equals 130 minutes. The second equation comes from the highlighted green, so that's going to be 2x plus 5y is equal to 190. Got it? All right. So, in the first example, we added inverses, right? Here we're subtracting. In order to make something equal to 0 with subtraction, it's just a number minus itself, right? So, do you see something that I can subtract from itself? 2x. Very good. So we're going to subtract the two equations. So we've got the 2x's that we can subtract. That 2x minus 2x is equal to 0, so that cancels out. We've got 3y minus 5y, which is going to give me -2y. And then 130 minus 190 is going to give me
-60.
Yes, -60. So now I can divide by -2, and y is equal to 30 what? 30 minutes. Minutes. Very good. So now I can substitute to see how many. Oh, this is 30 minutes for what? For trucks. For trucks. So now we can find out how long it takes for the cars. So we'll take that 30 minutes and we'll substitute in for y in one of the originals. Okay? So we've got 2x plus 3 times 30 is equal to 130. So 2x plus 90 is equal to 130. Subtract 90 on both sides. So 2x is equal to 40. Divide by 2. And x equals
24 cars.
Good. 20 minutes for the cars. And there you have it. Problem 3 is solving a system by multiplying one of the equations. So here we have negative 5x plus 2y is equal to 4, and we have 3x plus 6y is equal to 6. Do you see any inverses up there? No. Do you see anything that's the same up there? No. So that means we have to make it the same or make it an inverse. So, what can I do, Aiden?
You can multiply the top one by 3.
Very good. We can go ahead and multiply the top equation by 3. And when we multiply this top equation by 3, I mean you're going to multiply the entire, every term by 3. You with me? All right, so I'm going to rewrite down below, okay? So we've got a negative 15x minus 6y is equal to 12. So now we have inverses. Are we going to add or subtract? Very good. There are my inverses. So now we will add the equations. So those inverses, of course, cancel out. We end up with, let's see, 3x plus a negative 15x is negative 12x is equal to 6 plus 12 is
18.
18. Uh-oh, we're going to get some fractions in here, right?
No, you can make it decimal.
No. So we're going to divide by 12. Negative, thank you. And x is going to be a negative. Let's see, we're going to divide by 6. Simplify by 6. So this is going to be
3 over 2.
over 2. So 3 halves. So there's our x. So now we're going to take that x and we're going to put it where? Near one of the originals, right? So let's put it in, which one are you going to put it in?
The first one. If you want the first one.
The first one, well, let's see. If I put it in the first one, if I put that in for x, well, I guess if we're going to end up with fractions on either one.
Doesn't matter.
All right, so we'll substitute into the original right there. So we have negative 5 times a negative 3 halves, minus 2y is equal to 4. So this is going to be a positive 15 halves minus 2y is equal to 4. Now I want to subtract 15 halves on both sides, right? So I'm going to subtract 15 halves here, and I'm going to subtract 15 halves there. But, oh no, what do I need?
Common denominator.
Common denominators. So how do I make 4 with a denominator of 2?
You multiply 2.
So this is going to be
8 over 2.
All right, this is going to be 8 over 2, right? So this cancels out. We've got negative 2y here. And let's see. 8 minus 15. So that's going to be a negative 7 halves. Now, how do I get this y out of here? Divide by a negative 2, or, because I have fractions over here, multiply by
1 half.
negative 1 half, right? So I'm going to multiply times a negative 1 half over there too. So the 2's, the negative 2 and the negative 2 cancel, and we're left with y is equal to a negative what? 7 fourths. Very good. So my solution is what?
Negative 3 halves, comma, negative 7 fourths.
Very good. And that's your solution.